And everything I've showed you so far, like asking these, that would be a multiple choice question. Nothing like crazy. It's like, is the limit from the left, limit from the right. Okay? All right. So, let's look at the first one. 2 negative means 2 from the left. As I approach 2 from the left, every day. I don't remember it. Every day. Like a bad remembering cat. Okay. From the left, what am I approaching? 3. From the right, what am I approaching? 1. Now, guys, just so you know, in calculus, this is called the jump discontinuity. Now, the reason why we didn't have to talk about jump discontinuities in 30-1 is we didn't do piecewise functions, right? So you didn't have the jump. So you have jump discontinuities, or in calculus, you have removable discontinuities. You guys called them points of discontinuity in 30-1 because you had to, because that's the curriculum stated. But in calculus, they call them removable discontinuities. It is the same thing as point of discontinuity, but a different word, and you need to know how to say it. Okay? So it's the jump. Now, do these two match? No. So the limit from the left is good. The limit from the right is good. The limit at x does not exist. All right. Then we have 5 from the left. 5 from the left, what's it approaching? It's approaching 2. 5 from the right, it's approaching 2. Once again, we have a removable discontinuity here. When we have a removable discontinuity, our limit is just that value. It's 2. Okay? Jump discontinuities result in does not exist. Removable discontinuities result in the actual limit existing. And then they want f of 5. F of 5 is 1. So, I want to draw your attention to this. If I ask you if the graph is continuous at 5, you would say what? No, it's not continuous at 5, right? Now, how do you say that it's not continuous? In order for a graph to be continuous, what has to happen? Can you remember? Went over this on the last day before the weekend. Yeah? There's no breaks. So the limit and f of that function have to be the same thing, correct? So you have to say the limit as x approaches 5 equals f of 5, and then it would be continuous, right? And then you say, therefore, the graph is continuous at 5. Is that the case here? Is the limit the same as f of 5? No. So if we wanted to talk about continuity, we could say the limit as x approaches 5 of f of x does not equal f of 5, and then you come on board. Then you could say, therefore, the graph is discontinuous or not continuous at x equals 5. So, to prove continuity and to prove that something is not continuous, you do the same thing. One's just equal to. When they're equal to the same thing, then it's continuous. When they're not equal to each other, then they're not continuous, right? Because the graph doesn't just keep going. All right. It didn't ask that. I'm just proving something. Okay. Here it says, for the function f, whose graph is given, state the value of given quantity if it exists. If it does not exist, explain why. So we have the limit as x approaches 1 from the left. What's it approaching? 2. Limit as x approaches 1 from the right. What's it approaching? 3. Then at x equals 1 does not exist. And how would you explain that? Well, you'd say the limit as x approaches 1 from the left and the limit as x approaches 1 from the right are not the same value. Therefore, the limit cannot exist. Right? And then x approaches 5. Here's 5. So x approaches 5 would be from the right and the left. What's it approaching? 4. And what's f of 5? 4. So what could you tell me about 5? The limit is 4. F of 5 is 4. So what can you tell me about the graph? Yeah? It's continuous. If the limit as x approaches 5 of f of x equals f of 5, then the graph is continuous at 5. X equals 5. Okay. 14. Limit as x approaches 0. So from the left and the right, it has to be approaching the same thing it is. It's approaching 3. Then 3 from the left. As I'm approaching 3 from the left, it's approaching 4. As I'm approaching 3 from the right, it's approaching 2. So therefore, x approaching 3 does not exist because they approach different values. And f of 3 is 3. So not the moment that the limit fails or f of 3 doesn't exist, the graph can't be continuous, right? Because they have to result in the same answer. Okay, 15. For the function g whose graph is given, state the value of the given quantity if it exists. If it does not exist, explain why. So limit as x approaches 0 from the left. It's approaching that -1. And then 0 from the right. It's approaching -2. So what's it at 0? Does not exist. And then 2 from the left. It's approaching 2. 2 from the right. It's approaching 0. It's confusing on my graph. And then 2 does not exist. What's g of 2? 1. And what's the limit as x approaches 4? 3. Okay. Then we have this one, 16. As x approaches 3, what does it approach? 2. As it approaches 1, what does it approach? -1. As it approaches -3, what does it approach? +1. As it approaches 2, 2? Oh, that's 2 from the left, sorry. 2 from the left is 1. 2 from the right is 2. 2 is? Does not exist. Okay. And this is when you have piecewise functions. You have proof from the left and the right. If the graph's continuous, you can just find it at that value. Yeah? Yes. Okay, this is 0 from the left. It's approaching -1. 0 from the right. It's approaching 4. 0 does not exist. 2 from the left. Approaching 1. 2 from the right. 6. What is this? Is that a 1? X approaching 1 and approaches what? 1.5? Where is it? I threw over it. 1.2? 1.5? 2 point? It's not a 1 at all. 2.5? Yeah. Okay, then we're going to flip over. So if you look at f of x, this top graph is a line, the bottom graph is a line, correct? So the graph is continuous everywhere except for possibly the changing, that -5 situation. Now, this is a piecewise function, so the only way I can prove that a limit exists at -5 is to be proving from the left and the right they approach the same thing. So that's what I have to show, and you have to show this too. So if you didn't write it down like this, don't be like, it's fine. It's not. You have to write it down the way I do. If you don't have a limit, even the word limit anywhere on your page, that's a problem. So we're going to have the limit as x approaches -5 from the left. So that means I am looking for the equation where it's less than -5, which some people try and pick the top one. You actually have to look at the question. So this one says less than, yes? So this is the equation I'm going to put. So I'm going to write that beside it, 3x plus 14. If you didn't write it in this format, you need to. The limit as x approaches -5 from the left, write out the equation that's less than. Then in our next step, we're going to plug in the -5. And the moment we plug in the -5, we can drop the limit off the moment we substituted it. So we get 3 times -5 plus 14, and you get -1. So then I know as the limit as x approaches -5 from the left is -1. You have to show all this work. You can't just get like -1, -2 and say that they don't exist. You have to show limit from the left and write the equation exactly like I did. Then we have to do the limit as x approaches -5 from the right of this. So right is greater than. So we're going to put -3x minus 17. And so I get -3 times -5 minus 17, which is 15, minus 17, which is -2. The left and the right don't equal the same thing. So first off, this graph is not continuous, right? So from the left, as I'm approaching -5, it's approaching -1. As from the right, as I'm approaching -5, it's approaching -2. There's a graph going on here, right? From the left, it's a closed dot at -1. From the right, it's an open dot. There's a gap. So does the limit exist? No. So you're going to say this. Therefore, the 3 dots, you do a 3-dot triangle. That means therefore, the limit, bless you, as x approaches -5. Now people are like, I don't know what equation to use. You don't use an equation. This is f of x. You're trying to find the limit as x approaches -5 of f of x. So you put an f of x now. Does not exist because they didn't match. Okay? Proper formatting. You need it. The questions aren't going to be like tricky, but if you don't do it the way that I'm showing you to do it, you're not getting the marks. So it's not that people find it hard to do the questions, it's that they don't actually follow the formatting I tell them they have to. Yeah.
Does your answer have to have like 3 dots without and limit, or can it just be the 3 dots and the limit?
You can go 3 dots limit. Yeah, that'd be fine. All right. So for this one, we have the limit as x approaches -10 from the left. I need the less than equation, which is this one. So I get square root x plus 19 minus 11. Do you see how I did not fill that value in right now? I wrote the limit as it approaches -10 from the left, and then I write the actual equation, and my next step is to substitute in. Yeah. So I'm going to, when I substitute in, the limit goes away, so I get the square root of -10 plus 19 minus 11, which is the square root of 9, which is 3 minus 11, which is -8. Then I do the limit as x approaches -10 from the right. So I need to use the greater than or equal to one, so it's this one. 3 times -10, oops, I didn't have to write the equation first. 3x squared plus 2x minus 285. So I'm going to get 3 times 10 squared plus 2 times 10 minus 285. So I get 300 plus 20 is 320 minus 285 is negative. I don't even remember what number I said. 320. Negative 35. Positive 35. Anyone? Yeah, but -10 squared. Oh, right. Woo. I'll be here all week. Don't worry. It's going to get worse. All right. What do we have? -5? I agree. Do these match? No. Therefore, the limit as x approaches -10 of, once again, f of x. You can watch yourself, because sometimes a piecewise function has like a g of x in front of it or an h of x in front of it. You have to use what the heck letters there. You can't just use f of x because you like it. These are all f of x's for your welfare, but doesn't matter. All right. Okay, then we have to do the limit. As x approaches 11 from the left, this is the less than one, x minus 6 equals 11 minus 6, which equals 5. And then we have the limit as x approaches 11 from the right, which is the greater than, which is a lot bigger. 4x squared minus 2x minus 457, which equals 4 times 11 squared minus 2 times 11 minus 457. What did you get? What did you get for an answer? 6. Do they match?
Sorry, not 5.
I was going to say, I think they're supposed to be the same. I think one of the top two don't exist. Therefore, the limit as x approaches 11 of f of x equals 5. And then we have the limit as x approaches -6 from the left. This is the less than now. So we get square root x plus 10 plus 1, which is -6 plus 10 plus 1, which is 5, 3. And we have the limit as x approaches -6 from the right, greater than this one. So we get 5x plus 33. 5 times negative 6 plus 33 equals 3. Therefore, limit as x approaches negative 6 of f of x equals 3. Then we have 5, which is 12. Here's the limit as x approaches 12 from the left, which is the less than. So we get 4x squared minus 3x minus 534, which equals 4 times 12 squared minus 3 times 12 minus 534. Is it 6 or something? 6? And the limit as x approaches 12 from the right, x minus 3 plus 3, square root 12 minus 3 plus 3, which is 6. Therefore, the limit as x approaches 12 of f of x equals 6. All right, I have one more thing.